Dear students, see that the next one, class 11th, motion in a straight line, NCERT example problem number 3.5. Okay, see the question. It is based on free fall. Actually, the free fall means just we give, no need to give any initial velocity, just we leave the object. So no need to throw. Okay, so no need to throw, just we leave the object. Okay. So that means that the initial velocity is 0. Just I have to leave this object at particular height. Okay, so here the initial velocity is 0, that's all. Okay, so that is free fall. Okay, so in this free fall, discuss the motion of the object under the free fall, neglect air resistance. So some air resistance are there while we leave the object, some air resistance are there, so don't bother about. Okay, so now we are going to discuss for free fall object the motion we want to discuss. So first we must understand then what is that the free fall, then what about its that acceleration, what about that value. Okay, so for your convenience I'll give like some sentence. Okay, so let's discuss one by one. Okay, see that an object is released near the surface of the earth is accelerated downwards under the influence of gravity. Under the influence of gravity, because if I take this object, now I have to just leave this object. Okay, so if I leave this object, it is moved to allowed under the action of gravity. Okay, so no need to give any initial energy, no need to throw this. Okay, just leave the object, it is moving in downward direction because due to the gravity, acceleration of the gravity, or acceleration due to gravity, the force of attraction of the earth. Okay, the next one. So okay, it is attracted by the earth. Okay, so it having some magnitude, some value, So the magnitude of the acceleration due to gravity is represented by letter G, small g, not capital G, small g. So that small g value, that is a 9.8 meter per second square. Okay, 9.8 meter per second square. That is acceleration due to gravity of the earth. Okay, this is for earth. Then if some other planet, the g value will be varied. Okay, right. So now you know what is the gravity force, what is its magnitude, Next one, if an air resistance is neglected, so the object is said to be free fall. Okay, so that is the meaning of free fall. Okay, because whenever we leave the object, here some air resistance are there. Little bit air resistance are there. Even we are moving here and there, here air resistance are there. But anyhow, it will be neglected. Okay, here air resistance are there. Now I move my hand, here some air resistance are there. Okay, now I throw something, here air resistance are there. But we didn't bother about because we neglected. Okay, so in that situation, okay, so if an air resistance is neglected, the object is said to be free fall. Okay, so now I leave this object, air resistance is neglected, so this situation we call as this is free fall. Okay, so no other disturbance. Okay, so first point about what is that force, second point about what is that magnitude, then third point the condition because the air resistance is neglected. The fourth point, it's a sign value. So by even the previous question, the 3.4, if you observe that if the object if you throw upward direction, it is opposite to the gravity, so that the acceleration we got minus g. If it is moving downward direction, that is towards the earth, that acceleration is plus g. So in previous question I said, but now okay, the concept is same, but we are going to draw the graphical diagram. Okay, for that purpose I write here the acceleration due to gravity is downward direction. Okay, it has that negative direction. Okay, because it's very important point, so don't need to confuse. Okay, so while we draw the graphical diagram, you understand. Okay, So the acceleration due to gravity in the downward direction. So if I say, for example, it is a x-axis, x dash axis, and y dash axis. Okay, now if I leave this side, it is the origin. This side, for example, this side is x-axis, x dash axis, y-axis, y dash axis. If I leave the object, means object travel towards to the y dash axis. Y dash axis is nothing but absolutely negative. So that purpose only I wrote negative. Okay. Okay, students. So what we learn from this situation? In this situation, how the equations of motion will be vary. Okay. So it's not new one. So that equation, that is the first one. V is equal to u plus at. Okay. So if you leave this object, initial velocity 0. So no need to give any other initial velocity. So initial velocity 0. U is taken as 0. And then a value taken as minus g because this y dash axis. So v value v, u value 0, so it will not come. A is equal to minus g, so minus g. So v is equal to minus gt. What about the g value? Minus already is there, g value 9.8, so 9.8 t meter per second. So this is one result. Okay. And then second one, like that one more equations, that is s is equal to ut plus half at square. Okay. So it is moving downward direction. It is cover the height. There is a displacement s. So s is considered as h. Then acceleration, that is a is equal to minus g. That's all. Then initial velocity, as usual, initial velocity 0. So s is h. Initial velocity 0. So u is 0. So this term will not come. So 1 by 2 is there. A is equal to minus g into t square. So minus 1 by 2 into g value what? 9.8, then t square. So 9.82 cancel means minus 4.9. So h is equal to minus 4.9 t square meter. It's very important, meter. Here unit is meter per second. Here the unit is meter because it's a height. Okay. Like that, the third equation, v squared is equal to u squared plus 2as. The same thing, initial velocity is taken as 0. Okay. Then height is s is equal to h. Then a is equal to minus g. So replace here v squared. This value is 0, so it will not come. So 2 as usual, a is equal to minus g, s is h. Therefore v squared equal to minus 2 into g value 9.8 into h. So 2 into 9.8, 19.6. So v squared equal to minus 19.6 h meter square per second square. Okay. So in this question, already equations of motion is there. So that equations of motion is common. So now we can write specifically for freely falling body how the equations of motion is changed. So like that we derived. Okay. So the equations of motion 1 and then 2 and then 3 is derived. Okay. And the next one we are going to discuss how the graph will come. Okay, that velocity time relation and then the position time relation. Yes, position and the time relation and the position and the velocity relation. So in that relation, how we are going to draw the graph, especially for free fall. Okay, so that is the next one. Okay. Okay, see that here I draw the 3 types of graph. The first graph, there is a relationship between acceleration and time. Then second graph, relationship between the velocity and the time. Then third one, there is a relationship between the distance covered by the object or the position and the time graph. Okay, so these 3 variation, especially for free fall object, how this graph will be represented. So we'll discuss one by one. See that the first one, okay, the first one, acceleration and the time. Okay, for example, let's take this object. Okay, so now I leave this object. So let us, now the time is now 0. Okay, and after 1 second, for example, now 0, after 1 second, object here. What is the gravity here? Same 9.8. Then 2 seconds. After 2 seconds, What is the gravity here? Same 9.8. After 3 seconds, 1, 2, 3. So after 3 seconds, what is the gravity? 9.8. Because you know that 9.8 meter per second square is constant for our Earth. Okay. So little bit variation is there, that is different, but I didn't discuss about that. Okay. So anyhow, the acceleration due to gravity is constant. Okay, so whatever the time value will be varying. Here, what is the gravity? In this point, what is the gravity? 9.8. In this point, what is the gravity? 9.8. Now, what is the gravity? 9.8. 9.8 meter per second square. Okay. So, the acceleration due to gravity is constant. Okay, constant for the Earth. That is 9.8 meter per second square. Okay, that means what is the meaning? 9.8 meter per second square value will not change. Okay, for your understanding purpose, I draw this graph initially. See that this is the acceleration, or here it is the acceleration, here it is the time. See that time value increasing 1 second, 2 second, 3 second, 4 second. But here, see that 4, 8, 9, 9.8. So see that whatever time value change, 1 second, 2 second, 3 second, 4 second, whatever, in one second, first second also 9.8, second second also 9.8, third second also 9.8. So that A value, that is a gravity value, will not change with respect to the time, because acceleration is what? Constant. Okay, you understand this graph. Okay, the same graph we'll see here, because now the object is, we consider as free fall, moving downward direction. So let's say take the same thing only. First second, second second, third second, fourth second, in all the second. What about the G value? 9.8. 9.8, see that here minus 10, minus 5, here minus 10. So near the minus 10, because this is, we represent as minus 9.8. Okay, so this is acceleration and time graph for free fall body. Okay, clear? Time whatever change, the acceleration is constant. Okay, so the first graph is over. Then the second graph, variations of velocity and time. Okay, so now only I said acceleration is constant. Okay, so by using that one more graph, it will helpful for you. Okay, the same idea. See that for this, in x-axis, y-axis velocity, x-axis time. Okay, so velocity and time, what will come? So you know, acceleration is equal to change in velocity divided by change in time. You know this idea. Okay, so the slope should be velocity and time. So velocity time, we can get acceleration, but acceleration due to gravity is constant. Up a constant acceleration means how the diagram will come, how the graph will come. It should be the straight line like the slope. It is constant. So we can get any time here, 1 second, 2 second, or anything. Here the velocity something. So this is, you know, delta V or dV. Okay, or dV or delta V, anything. Okay, dV. So this is, you know, dt. So acceleration equal to dV by dt. Okay, so this is, you know, the constant. So the relationship between velocity and time is constant. So if it is constant means what will come? The line should be like this from the origin. The same thing only. Now the free fall body, it is moving downward direction. So I use, what is it? Negative y-axis. That is y dash axis. So the same graph only here. I hope you understand now. So please listen. The same graph. Whatever the time value, the time value also increasing, that velocity also increasing. Okay, now I leave this object here. In first second some velocity, in first 2 seconds velocity increased, in first 3 seconds velocity again increase. So first second little velocity, 2 second means velocity increase, 3 second means velocity again increasing. So when the time is increasing, velocity also increasing gradually. So it's a directly proportionality. So like that this graph will come. Okay. Then third one. So I hope you understood that the second graph, velocity and the time graph, it should be the constant. That means what? Constant acceleration. Okay. The third one, the variations of S and T. S and T. So you know very well. Okay. That example problem in the 3.6 we are going to discuss about that. Anyhow, see that for first, now I leave the object. First second, in 1 second, the distance covered by the object, this much distance. Okay. Now say for example 1 meter. For example 1 meter covered. Okay. In 2 seconds, we expect, okay, 2 meter, but not 2 meter. In first second 1 meter. In second, okay, first second 1 meter, okay, next second not 1 meter, 3 meter will move. Okay, so first second 1 meter, second 2 meter, 3 meter, third second 5 meter. Okay, like odd number something will come. So the gradually increasing, the distance covered by the object is gradually increasing. Okay, it is not uniform. Gradually increasing. So gradually increasing means how the graph will come. Okay, for understanding purpose, see this. It's a position. It is the time. So gradually increasing. So in the first second, object here. Second, gradually increasing. Fourth second, gradually increasing the distance. It's not constant. It is not uniform. Okay, first second 1 meter, second 2 meter, third second totally 3 meter, fourth second totally 4. Not like that. First second 1 meter means next second 3 meter. Okay, so like that, gradually increasing. So gradually increasing graph like this only. Okay, but you know now the object is traveling in a downward direction. So for that purpose only, I draw the graph in that y dash. Okay, or otherwise the y dash. Okay, y dash. Okay, so the same thing only. The graph will be first second maybe for understanding purpose. In first second, for example, 10 meter. Okay, in second not 20 meter. Okay, second maybe more than 20 meter. Next third second more than 30 meters. Then something. It is increasing. It is approximate diagram. Anyhow, it is not uniform. Gradually value is increasing. Okay. Okay. So regarding the position and the time, example problem 3.6, we are going to calculate accurately. Okay. Okay, students. So now you can get some idea about what is a free fall body. In that free fall body, how that equations of motion value will be vary under the action of gravity. And then how that the response of acceleration and time graph, and then velocity and time graph, and position and time graph. Okay, so I hope you understood. Okay, thank you.